Hello everyone. This evening I have created a couple of data sets for you to examine the percent of data as it's dispersed between the mean and a given standard deviation. To work this problem, I need you to first take these two data sets, class 1 and class 2, and enter this data into your calculator in the appropriate list. You do not have to sort your data, although it might be helpful in calculating the mode. So if you want to pause the video right now and enter your data and then join back in, that would be just fine. Okay, so if you've been away and now you're back, what I need us to do is to calculate the sample statistics for our two data sets. So beginning with L1, I need us to calculate your mean, median, and mode. We can do that by going through second stat math and checking those out. So if you want to do second stat math, L1, and you can go down through, find mean, tell it L1, and in doing so, we should find a mean value here of 36.1. If you then go back and do it again, you can look up median, which is 37.5. And for mode, you're going to have to go right through your data set. It doesn't have a secret place in your calculator to tell us that. So I see for data set 1 a 35, a 40, and a 42. Okay, so as we're sitting here, or as I'm sitting here writing out your notes, it occurred to me that you may not do second stat math at this point. You may actually want to do one var stats to pull up these statistics, and if you did that, that's also fine. Okay, so that would have been an okay way to find your mean and median. Okay, all right, let me see what else we need here. Oh, I skipped over standard deviation. Okay, so again, if you're on your calculator there at one var stats or second stat math, if you can pull up your standard deviation for this data set, you're going to find that to be an 8.6. Okay, so our task at hand is to now take the values for our, see if I can highlight over this, mean, which is here at 36.1, and then use our standard deviation and create a number line based on those two values, mean and standard deviation, and then plot our data points for class 1 and get a look at what the dispersion of data is. Okay, so I'm going to scroll down here just a bit, and I've created a little number line. And what I'd like you to do on your notes is to mark your mean in the middle, as just kind of guesstimate where you are here. So we'll mark that in as X bar. In fact, I'm going to shift colors here. Okay, and that value for us is 36.1. Okay, and I'm just strictly using the class 1 values from up here above. Okay, so then I'm going to add 8.6 to the right. So I'm going to go 1 standard deviation to the right. So I'm taking 36.1 and adding 8.6. That should give us 44.7. Okay, then I'm going to do it again. So these steps on the number line, the size is the standard deviation. All right, so I'm going to be 2 standard deviations to the right. And these are S's, they're not 5s, they're S's for standard deviation. Okay, so that's going to give me 53.3. I'm going to go 1 more standard deviation to the right, so 3 deviations to the right. So I'm adding 8.6 again, and I get 61.9. Okay, so we're just going to go 3 places to the right. We're going to do the same fashion to the left, but instead of adding the standard deviation, I'm going to subtract it. So subtract 8.6. So at this case, we're going to end up here at 27. I should have dropped that down just a bit. Well, we'll sneak it in here. 27.5. Okay, we're going to go another standard deviation to the left. And again, negative 2s, so 2 deviations to the left. So subtract 8.6 and you're at 18.9. subtract 8.6 again, so that we're 3 deviations to the right. Now we're at 10.3. Okay, so that's the values of our number line. The size of the steps on the number line is the standard deviation, 8.6. Okay, so on your calculator where you have your data sorted, okay, so from smallest to largest, the first number in is a 17. Okay, and actually the lists are sorted on the worksheet, huh? Pretty observant there tonight. All right, so 17. Figure out where 17 would fall in the number line. So as I'm looking at this, okay, 17 is going to fall between 10.3 and 18.9. Okay, so got that number done. Next is a 20. Okay, 20 is going to fall between 18.9 and 27. So we're going to put the 20 in here. Okay, next up is a 21. So 21 also is in the same little compartment here in this range. And then the 25 will also fall in there. Okay, so I'm down to here. All right, then 28 is going to have to slide over into the next category, compartment. So we have a 28, 30, also between 27.5 and 36.1. 31 goes there. 34. 1, 2, 3, 35s will still be in here. Okay, and then 36. So we're down to here. All right, now I'm going to go to 37. So I'm going to have to put that in the next compartment between 36.1 and 44.7. Okay, then we'll have a couple 38s in the same zone. 3 40s will also be in here. Okay, so I'm down to 42 is still in this region, so we have 3 of those. And then a 43 all the way to 44. So 43 and 44. Okay. Next number is 48, so we're going to have to slide over. It'll fit into this next compartment between 44.7 and 53.3. And then a 49, that's also in here, and another 49. Okay. All right, so my question for us now is, now that the data is spread out into the different little compartments, what percent of the data, okay, I'll change colors here, what percent of the data is going to be within plus minus, and I should make this so you see this is different, plus minus 1 deviation of the mean. So in other words, here's negative 1 deviation, or 1 deviation left. Here's 1 deviation right. How many numbers, that's kind of funny, are in this inside region? So in other words, we're just going to count them, okay? And if you didn't notice, there were 26 data points in this first data set. Okay, so let's go to counting here. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 data points within plus minus 1 deviation of the mean. So percent of data then would be 19. I gotta write small and it doesn't like it. 19 out of 26, or you could tell me that that is 73.1%. Okay, now we're going to kick out, we're going to go out 2 deviations from the mean. Okay, so here's 2 to the left, 2 to the right. Okay, so now all of these within these orange lines is plus minus 2 deviations of the mean. So we were at 19, so we got 20, 21, 22, 23, 24, 25 data values. So within plus minus 2 deviations of the mean, in fact, I'm going to draw it down like this. We have 25 out of 26 data points, which is 96.2% of the data. Okay, and then lastly, if we kick out to the third deviation, okay, so we're out here, plus minus 3 from here to here, plus minus 3 deviations, you'll see that we have all data points accounted for. So in the plus minus 3, we have everything. 26 out of 26, or 100% of the data. All right, so 73, 96.2, and 100 are our plus minus 1, 2, 3 deviation percentages. Okay, why is this important? Because I'm showing you some experimental data that will we'll have use of this to compare to something called the empirical rule as we go forward here just a bit. Okay, so let's see if I can get us through a second example. So if your class 2 data is already entered in your L2, okay, you're ready to roll. Okay, if not, pause the video and do that now. Okay, so if you're in your calculator, I'm going to guess again, maybe now you want to do one var stats. Just remember to tell it L2, because we're now in the second data set. I need you to calculate your mean, or tell me the mean, your median, and your mode, and then your standard deviation. And we want to use the S sub x value. All right, so for mean, I calculated 35.3. For median, 35.5. Mode, I saw 2 of them, so it's bimodal, 34 and 37. And this one has a standard deviation of 6.4. Okay, so again, we're going to calculate these percents of data in the different ranges. Okay, we care about the mean, the standard deviation, as far as building our new number line for the class 2 data. Okay, so I'm going to go down here and put together a number line. I have a second line here. We're going to start with the mean again. Okay, so my mean value, 35.3. We're going to go 1 deviation to the right. So this time I'm going to take 35.3 and add, what was that standard deviation up here? 6.4. And I get 41.7. Okay, 2 deviations to the right. So you're going to hit on your calculator plus another 6.4. You get 48.1. And do it one more time. 3 deviations, so I'm adding 6.4 again, 54.5. Okay, to go to the left, you're going to subtract. So 35.3 minus your standard deviation, 6.4, you get 28.9. Go to the left again, subtracting, and you get 22.5. And one last time, you're at 16.1. Okay, so if we again take your list of data, okay, and again it's in order, starting with the smallest here at 24, and we're going to plot those data points, okay, in the little compartments where they belong. Okay, so 24 is the smallest. Here's 22 to 28, so 24 is going to fall right here. There's a couple 24s, then you should find a 27 and a 28. Okay, between minus 1 deviation and the mean, you're going to have a 32, a 33, and you've got 4 34s. Okay, over again to the next, between 1 deviation and the mean, there's some 37s in your list, like 4 of them, a couple 38s. Okay, and then lastly, between 1 and 2 deviations, we've got 42, 42, 45, and 48. Okay, so again, we want to count the number of data values within plus minus 1 deviation of the mean. So the question is how many out of, and we didn't count up here, but if you look at your data, in this one, we've got 20 data points. Okay, so if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, good grief. I apologize. I'm in the wrong data set. Slide down a little bit. Try again. Within 1 deviation down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. We've got 12 data points out of 20 are within plus minus 1 deviation of the mean, and that's just a flat up 60%. Okay, if we go out 2 deviations, so from here to here, oh wow, look at that, we've got them all in this one. Okay, so that one's going to come out 20 out of 20, so we're already to 100%. So if that's the case for 2, then we've got 3 covered, same. We are already at 100%. Okay, so that's how we can take a look at data and its dispersion. All right, and you're probably wondering, okay, this was great fun and I like counting things, but why are we doing this? Well, in a future video, I'm going to talk to you about something called the empirical rule, which is the theoretical values that should happen within 1, 2, and 3 deviations of the mean. Okay, we have values here and over on this one that are experimental because this was some sample data. This is what happened in an experiment. Or according to a rule, okay, 68% of the data is expected to fall within 1 deviation of the mean. 95% of the data is expected to fall within 2 deviations of the mean. And then 99.7% of the data is expected to fall within 3 standard deviations of the mean. Okay, so that's where this is all headed. I wanted to show you one with real data before we get into the theoretical of what's called the empirical rule. Coming soon to a video near you. Thanks everybody. Have a great day.